This is an unscheduled video to answer a viewer question and correct an error. In the previous video about espresso recipes, I made an offhand comment to the effect that denser coffee beans need to be ground finer in order to hold the same pressure as low-density ones. And by hold pressure, I meant resist the flow of water. Not exactly the same thing, but you know what I'm saying. In the comments, a viewer asked, quite reasonably, why that is. And I answered that I don't know why, I just know that it's the case. The viewer then suggested that it might have to do with higher or lower proportions of fines. They were thinking that if you have a lot of fines, they'll get packed into the small spaces between larger particles, making the puck relatively more solid, thereby reducing flow. I said I would look into it and added a prediction that after testing, I would still be unable to explain it. The difficulty is that I misspoke in the first place. I said the opposite of what I meant, not for the first time either. Denser coffees tend to resist flow more than low-density samples. But the question remains, and we can still look into whether coffee density is connected to fines production and whether that figures into the differences in flow rates and shot times. Normally, I avoid questions with no practical application. The Wired Gourmet is about looking for ways to improve the flavor of your coffee, or save money on equipment and supplies, or reduce clutter and bother for a smoother workflow. The question of why one coffee sample needs coarser or finer grinding is hardly pressing. You're going to dial in any new coffee regardless. But I said something that created uncertainty, so I feel obliged, on principle, to clear it up, even though the question is academic. That said, I have got a result. If this piques your curiosity, then I'd invite you to stick around.
Oh my God.
It's like a miracle.
So, to state the obvious, the first question is whether sample density is connected to fines production. And the second question is, does that figure into the observation about flow resistance, and if so, how? I'll be using two samples of coffee, one very dense, hard, high-grown, and one low density, soft, commercial stuff. I'll use 3 grinders that have significant design differences. A Niche 0, which is a conical machine with large 63mm burrs, a Mahlkönig EK43, which has large 98mm flat burrs that are designed so that the sharp edges move away from each other. Think of the action like using a file on the return stroke instead of on the cutting stroke. And finally, a Niche Duo, which has 83mm flat burrs, whose sharp surfaces encounter one another in the conventional way. All 3 machines use commercial-sized burrs, so we don't have to worry about whether burr size is an issue. This will give us 3 pairs of samples for a total of 6. Once I dialed in each grinder, I split the difference between the 2 samples. That way I can use a single grinder setting for comparison. Of course, we have to separate and weigh the smaller particles, which brings us to a weak link, the Kruve sifter. This is nothing like a proper laboratory sieve. The margin of error here is generous. Each coffee sample will have 3 basic sizes of particles. Ones too big ever to pass through the screen, very small ones that will go through almost immediately, and ones that won't pass through the holes in one orientation but will in another. Those go through randomly, so you never really finish sifting. I'm using 20 grams of coffee. I've decided on a 0.4mm screen. I chose that size because it allows anywhere from 10 to 20% of particles to pass, and we'll call those fines. Often we think of fines as particles, say, 0.2 of a millimeter or smaller, those that will pass through a portafilter basket, which typically has 0.3mm holes. I haven't got a strict meaning for the word fines here. I'm just measuring small particles that might get packed into the spaces between larger ones and obstruct the flow. So, a little test run here. One thing I really hate about using this device is the amount of coffee grit that gets scattered around your workspace. It's difficult to empty this into a small container. Now let's look at the screen. Okay, this is total failure. The screen is heavily loaded, so I've got no idea how many more bits would have made it through if that hadn't happened. But this is almost certainly an undercount. I'll have to start over, and I think I'd better add a timer to the mix and shake each sample for 1 minute. I'm going to add uncooked rice to make sure all the coffee gets knocked about, and also to sort of scrape and push the stuck particles through the holes. I'm still using 20 grams and a 0.4 millimeter screen. Could this be a more idiotic design? Well, so long as the coffee spills onto the scale, I suppose it's not a problem. I did this a total of 5 times, and I got 4.5 grams. The maximum variation was 0.2, and I think that's an acceptable margin of error, so I'll just sift once for each of the remaining sample. It saves time and coffee. And we'll call each of the results plus or minus 0.2 of a gram. It turns out the rice works pretty well. The screen looks fine. The niche 0 gives us 4.5 grams off the high-density sample, and 3.6 off the low-density sample with the same setting for a difference of 0.8 grams. So high-density coffee means more fines in this case. The EK43 gives 4.1 grams off the dense sample. Using the same setting, I see 2.0 grams off the less dense one for a difference of 2.1 grams. Again, more fines go with more density. But that seemed like a big difference, so I ran the test again very carefully and got the same result for the first sample and 0.3 grams more from the second. So I'll go with the second try because I was extra careful that time. I'm calling it 4.1 and 2.3 for a difference of 1.8 grams. So the duo now. The dense sample produces a healthy 3.4 grams of fines. And the low-density sample, 3.3 grams. So a mere 1/10 of a gram difference, which is within the margin of error, so really there is no difference. This result suggests that while bean density and hardness probably do figure often, burr design can override it, so it's possible to keep most coffee samples in a pretty tight range of fines production if that's what you're aiming for. I think we can agree that denser, harder beans tend to produce more fines than softer samples. You're welcome to speculate about why. The next question is, why does water flow through the low-density beans at a faster rate? Why do we have to grind finer to compensate for that? You might be tempted to say, because the harder beans produce more fines, which kind of plugs up the works, but let's not jump to conclusions. Instead, let's look at a few shots. This is the niche 0. First, the low-density sample, 16.5 grams. And we're looking at 40 grams yield in 30 seconds, and that gives us a reasonable shot time. A bit faster than my personal preference, but within the normal range. So now I'll do one using 19 grams of the high-density coffee with the same grind setting. I need a heavier dose to get the same volume, the same puck dimensions. And yeah, definitely running slower. We get 40 grams in 42 seconds for a 12-second difference. But is that due to fines? Let's try the niche duo, which gave us the same amount of fines in both samples. This should show us if the fines are implicated. Here's the low-density sample, again 16.5 grams, and it's a bit slower than the previous shot, more like the shot times I personally prefer. That's 40 grams in 38 seconds. And now the denser sample on the same grind setting. And sure enough, it's significantly slower. Very slow to begin. And we get 40 grams in 50 seconds, again for a difference of 12 seconds. So the shot times differ by the same amount with both grinders. And since the Zero produced noticeably different amounts of fines in the two samples, and the Duo produced the same amount in both, I think we can rule out fines as the likely cause of this time difference, or flow difference. Of course, I had to use different weights to fill the portafilter basket correctly to get 4 mechanically sound shots. I could have used doses of the same weight with different baskets. A smaller basket to accommodate a 16.5 gram dose using the denser coffee. But the simple fact is, I have to change one of those factors. The question is, which change would do less violence to the experiment? Using 2 different weights of coffee with the same puck dimensions, or 2 different puck dimensions with the same weight? I doubt we would notice much difference either way. So while fines production depends on the grinder, and seems also to be connected to bean density, the phenomenon of differing flow rates or shot times that we're looking into remains a mystery to me. As for why it happens, I'm going to stick with I don't know. This is a really complex problem. Think about what we're dealing with. We have a hot, pressurized solvent pumped through a semi-soluble bed of particles of varying sizes and shapes. All of the variables are constantly changing during the shot. The temperature goes up, the pressure goes down, the rate of flow increases, liquid viscosity decreases, soluble solids are being carried off, bed permeability changes, but perhaps not steadily, friction between the particles changes as water gets between them, and turbulence probably increases, although perhaps not steadily. And if that weren't enough, there are chemical reactions happening too. No one understands what's going on in there. No one. Anyway, that's about all for today. My next coffee video will be introducing the new ECM Synchronica 2, which has had some significant updates. I'll be buying mine from our good friends at homecoffeemachines.ie. They are not a sponsor. I'm just saying I've been doing business with them for a while, and I'm very satisfied with their prices and service. As for the next video, well, it won't be about coffee, but I think you're going to like it. So keep in touch. Cheers.